Kia ora, Year 12. In this video, I'm going to go over how we can solve normal distribution problems when we start off with a real life situation. In other words, we're going to learn how to go from X, a variable which is a real world thing like an apple or a giraffe, to Z, our standard normal. And remember that Z measures how many standard deviations above the mean we are. So for the Z random variable, it's normal and it has a mean of 0 and it has a standard deviation of 1. And to solve normal problems, we turn every problem into a problem about Z first. So we're going to be using this formula over and over. All it says is I take my number for my real life thing and I look at how many standard deviations above the mean it is. In this video, I'm going to work with a made up example of apples. So the apples weigh, not weight, the apples weigh on average 150 grams. So that's mu is equal to 150. They are normally distributed, those weights, and they have a standard deviation of 20 grams. So what I've got here is 6 questions that will step you through the different patterns that we see, and we're going to be using the normal table for all of these. Now, shortly I'm going to teach you how to do this on your calculator. Probably going to wait till we're back at school to do that. But it's very important that you understand what we're doing so that you can apply these skills to more complicated problems. So the first one, we've got the probability that an apple weighs between 150 and 170 grams. So if we're looking here, if this is my X normal variable, my mean is 150 and 170 is out here. So I want to find the probability that my apple X is between 150 and 170. So we know that this is going to be an easy one in the table because the table is set up in that pattern. So all I need to do here is to change those X values into Z values. So Z for the 150 is pretty obviously going to be 0, but I'll show you how that formula works anyway. Right, so it's going to be 0 divided by 20. For the second one, you can see that I've picked an easy one to start with. 170 is 1 standard deviation above the mean. But here's how we find the Z value using the formula, because obviously the example is not always going to be that easy. So we've got 20 divided by 20, which is just 1. So for this first problem, let's get rid of all the Z value stuff. What I'm saying is that I'm trying to find the probability that Z is between 0 and 1. So there's my Z picture. I can go straight to my normal table. I look through here and I go down to 1.0 and the answer is 0.3413. Okay, so that's the first one done. Now the second one is the probability that an apple weighs between 150 and 188 grams. So it's very similar to the first one. The difference here is that the Z value is going to be something a bit messier. So Z is equal to 188 minus 150 divided by 20, which gives me 38 over 20, which is 1.9. So first I write my statement about the probability with X, and then I write it about the probability with Z. And I show my calculation for where that Z value came from. So now looking on my table, what I want is the area between 0 and 1.9. So again, it's a nice easy one because it fits the table pattern. So we go down the table to 1.90, and my answer is 0.4713. Okay, if you're feeling confident, you could try the other questions now, but please make sure that you go over the answers because they're going to get slightly more complicated because they won't fit the picture that we want on the graph. So number 3, we want the probability that an apple weighs more than 170 grams. So we know the Z value, but what we want now is a probability in the upper tail. So there's 170, so we want this probability. So remember from the earlier video, we're going to be doing the thing where we subtract this probability from 0.5. So that Z value is still 1, right? We've already worked that out from back in here. So question 3 is the probability that X is bigger than 170, which equals the probability that Z is bigger than 1, which is going to equal, wrong slide. So it's going to be 0.5 minus that number there. 0.5 minus 0.3413. Now 0.5, because remember the distribution's symmetric, so I've got 50% or 0.5 on either side. So my answer here is 0.1587. Okay, next one, the probability that an apple weighs at least 162 grams. Well, that's very similar but we need to find a new Z value. I thought I'd give you a bit of Z value practice in this video. So let's change the picture. Always do your picture and colour it in. So we want the probability that X is greater than 162. So Z is equal to 162 minus 150, the mean, divided by 20. And that works out to be something. That works out to be 12 over 20, so 0.6. So in my Z picture, I want the area above 0.6. So again, it's going to be a 0.5 minus this number here, minus 0.2258, giving me a final answer of 0.2742. Okay, very quickly on to questions 5 and 6, because I've got to teach a Google Meet in 5 minutes. So number 5, we want the probability that an apple weighs between 140 and 150. So this time you can see that we're on the other side. Here's 140 and here's 150. That doesn't make it any harder, but it means that my Z value is going to be a negative number. So we're 10 below the mean. The standard deviation is 20, so my Z value is negative 0.5. So the probability that X is between 140 and 150 is equal to the probability that Z is between negative 0.5 and 0. But because of the symmetry of the graph, that's very easy to work out, right? So negative 0.5 here, we go to our table, we clean up the mess, and we go down our table until we get to this value here, which is 0.915. And that's my answer straight away there. Now the last question I'm doing here is the probability that an apple weighs less than 120 grams. So again, we start with our X picture and we colour it in what we want. And we're looking here for a lower tail probability, and it's quite far away. So we've got 150 here, maybe not that far away, and we've got 120 here. So Z is equal to 120 minus 150, so it's 30 below the mean. So it's negative 1.5. 1.5 standard deviations below the mean. And we want this tail probability. So it's the probability that X is less than 120, which is equal to the probability that Z is less than negative 1.5. So it's going to be equal to this. All of this side has an area of 0.5. We want this bit here. Unfortunately, the table gives me this bit here. So the last step of the calculation is to go, it's going to be 0.5 minus this number here, 0.4332, which gives me 0.0668. Right, hope that helps. Lots of questions on that in the Walker book. They go from pages 16 to 25, and worked solutions are up on Google Classroom now. Email if you've got any questions.